project title is Designing and Implementing a Scalable and Secure Microservice-Based Banking Application using Kubernetes and AWS. Let's look at our look at my problem statement. So I have done a good research on our existing banking systems about how the banking systems have been built and deployed at production. So our current banking systems, traditional banking systems, lack modularity, scalability, where most of the banking systems are built using monolithic architecture. So I have listed out the objectives of my project. So my first objective is to build a cloud native microservice based application, banking application. So microservice in the meaning each backend service will be isolated and modular, so that even if one service goes down, the remaining service will be up and running, which ensures our application uptime and scalability. So second objective is to ensure security and CI/CD, which is continuous integration and continuous deployment, and also observability. And the third objective is to deploy our backend services in Kubernetes cluster. EKS is a managed Kubernetes service from AWS, and using Route 53 for domain resolution and application load balancing as well. Now we will move to the next slide. So here I've listed the implementation details of my project. So first point is microservice-based design. So I have built a banking application using microservice-based architecture. So all my backend services are isolated and modular, and each microservice has its own GitHub repo as well. So which ensures individual developer contribution and parallel deployment pipelines. So next point is containerization and Kubernetes. So each backend service is containerized using Docker, and each service will be built as a Docker image and deployed in Kubernetes cluster in parallel, which also ensures scalability and high availability. And the next point is cloud native deployment. So my primary aim is to use cloud provider, a major cloud provider, which I've chose as AWS. So I have used EKS, which is a managed service, and I've deployed all my backend services as Kubernetes Docker containers in EKS cluster. And I have used also a bunch of AWS services, which is Route 53, ACM for SSL certificate, and other services as well. We will look at the architecture later in the next few slides. And the next point is service resilience, fault tolerance. So primary objective of any large scale application is to be fault tolerant. Even during huge spikes, the application needs to be up and running, and end user should not face any disruption at all. So we have ensured that using auto application load balancing and also replica sets, which we'll discuss in the architecture. And the last point is security. So as I mentioned before, our application should be very secure. So I've added the SSL certificate for our application and IAM roles for least privilege access, TLS termination and load balancing, and all other security best practices. Now we will move on to the application architecture. So this is my a very simple architecture of my application. I'll just quickly explain this. So we have three major services, which is front end, back end, two services, out service, flight service. So front end service, it's very isolated and it is built using Next.js framework, a popular front end framework. And back end, the blue boxes, those are the back end services. So the light blue box, it's out service. It is built using Golang programming language. So that out service handles all the user authentication and authorization. And the dark blue box, it's flight service. It is again built using Golang. So this handles all the banking and transaction related functionalities. And each service has its own database. Again, in traditional banking systems, we have a huge master database where you have hundreds of tables and millions of rows. Even if taking backups on ensuring high availability is very problematic. But in microservice design, each service will have its own DB, which ensures easy scalability and high availability. We can even spin up a database even if the primary goes down. So we have all the capabilities for ensuring high availability here. And as we can see, auth service will also communicate with flight service, which ensures service-to-service communication as well. And I have used a Redis session store, so which is used for storing user login sessions, and auth service will store all the user login sessions in Redis store. Now, as I've explained the application architecture, now we will move on to the deployment architecture, which is in AWS. So this is a very comprehensive architecture. I'll start with the EKS cluster. So I have deployed our EKS cluster in Mumbai region. It's AP South 1 and across 3 availability zones. And our cluster is running only in private subnet, which ensures high security. It eliminates all the security threats as well. So our backend service and DB and all our sensitive customer data is always secure. And so as we can see, our service backend services are running as containers. Each pod, in Kubernetes terms, it's called pods. Each pod is the smallest deployable unit in Kubernetes. So we could scale the pods across different nodes, different availability zones as well. So even as we could see, one availability zone completely goes down, we have our service running in other availability zones. So our end user will not face any disruption at all. Our application will be up and running all the time. And so on top of this cluster, we have load balancer. So application load balancer ensures load distribution across the nodes, across our backend services. So which also ensures not a single service will experience huge traffic, right? So it basically splits the traffic, distributes the load across the backend services. So on before application load balancer, we have Amplify. So Amplify is an excellent service from AWS, which is primarily used for deploying front-end frameworks. So as I've told, I've built the framework using front-end framework using Next.js. I have integrated my GitHub repo with Amplify, and it automatically pulls the code and deploy it. And so I have bought a domain name from GoDaddy, and I have mapped the domain name with internal routing in using Route 53. So again, Route 53 is a domain naming system, domain management system from AWS, which handles all the domain name resolution and internal traffic routing. And we have all our end users will first access our application from CloudFront, and it redirects to Route 53 for domain resolution, and it again goes to Amplify. And so from Amplify, all the static and dynamic front-end files will be served to user browser. So whenever user makes a backend call, request HTTP call, it directly goes to application load balancer, and our backend service will receive the request and respond back with the proper response. And we also have Amazon CloudWatch, which is used for monitoring all our AWS services, which can maintain the logs as well. So on the top, we have a workflow where a developer commits or pushes the code to the repo, and the latest code will be built as a Docker image and pushed to GitHub Docker Hub repository. So, and the latest image will be directly deployed to our EKS cluster. So this entire flow is called CI/CD, and this is achieved using GitHub Actions. So I have configured it in GitHub, and this will directly deploy the latest change to the cluster. Now, so in this cluster, in this slide, I've listed the outcomes of my project. So first point is a full-scale production-grade application with all the necessary security best practices and scalability metrics. So the next point is scalable and secure deployment. As we have seen before, we are using EKS cluster for deploying all our containers, and our current EKS cluster has 10 EC2 instances with T3.micro instance type. And we have HTTPS secured using certificate from certificate manager, Amazon certificate manager, and also load balancing, ingress controller, and CI/CD automation using GitHub Actions, infrastructure as a code, observability and admin dashboard, and mobile and cross-browser compatibility. So yeah, now let's move on to our application walkthrough and AWS console walkthrough. I'll give a quick walkthrough of our application.
Yeah, I don't require the demo here. You can skip the demo. Maybe you can just continue with the slides. I have seen similar demos elsewhere, so I understand what you're doing here.
Fine. So now we'll look at our AWS console, what I've done. in AWS. So this is our cluster, EKS cluster up and running. It has around 10 nodes, EC2 instance, and it is created, and all our backend services are running in this EKS cluster. Here is our AWS Amplify. It's a separate service, and this handles the front-end deployment. Here we could see the latest
No,
deployment.
I think we can skip all of this. Can we go back to the slides? This is fine. This part is fine. Can we go back to the slides?
Okay, sure.
So how many more slides are left?
Yeah. So
Oh,
that's
that's
it.
the last
This
slide. Okay.
yeah.
Okay. So I want to ask a few questions. So what do you mean by security here? Like you did talk about security here, right?
Yes.
Securing microservices. So what security? What is security here?
So here, security, I can define it in two major categories. First one is the application side. So application should be SSL certified, so that our in transit requests will be encrypted using SSL certificate. So I have implemented that TLS SSL encryption using a certificate from certificate map, Amazon certificate manager. So bought a certificate from there, and I've configured it in Route 53 for in-traffic encryption. And for microservices, our backend cluster is running in a private subnet. So any external traffic or any external user cannot directly access our backend cluster, this EKS cluster. So yeah, so that's what I meant here.
Okay, so here you don't have to implement any code, right? I mean, so these, so for example, you talked about what ECS certificate? No, which certificate did you just talk about?
Yes. So SSL certificate, I've bought it from AWS certificate manager. That's
Okay, so
ACM.
you okay. So sorry, uh, ACM, right? From AWS
Yes,
Certificate
correct.
Manager, you directly get it. So it's just a drag and drop kind of thing. You don't have to really implement something. So is there any implementation that you have done?
Yes.
Any code implementation or anything that you have done?
Code level, no. So the banking application that I've built, it is just a prototype. It is running in a sandbox environment where we could. This is just a demonstration of how the application can be scaled, uh, which can demonstrate the scalability and ensure microservice design. That's it. So I haven't done any security related code level implementation here.
Okay.
And
So
it has user authentication, user login, user logout. So
so even
any
those
user
you
can't.
don't have to log in. You don't have to create any code for this, right? So it's like so these things are inbuilt in the tool itself, right?
No, this application I have built it from scratch. This banking application. So this authentication feature needs to be written. So we have a separate service called auth service. So this will handle all the user authentication. Meaning, if the
Right.
user
So
wants.
basically, to create any of these, I mean, you don't have to actually write any piece of code as such, right? So these are all inbuilt tools which you just need to drag and drop here and there to make it work. Correct?
Uh, yeah, so I'll just explain it. So in this architecture, I have built it. I've written the code. This is our application code, and in this slide, all the AWS services. Yes, so I have configured it in the AWS console, and this cluster configuration, we need to write some code to deploy it to properly configure it, and to ensure each service will send the request to its respective service. So I'll just quickly show you the code as well. I have written it here. So here we have our manifest files, which are the configuration files for our EKS cluster, and here we have our backend code, the entire backend code. So this is for each API that I have written and DB calls. This is entirely I've written it using Golang. This is for backend integration